Right, in example 52, we're going to have more fun with permutations. Let's suppose we have 15 distinct math books, 12 distinct physics books, and 16 distinct computer science books. So meaning I've got 16 computer science books. They're all different books on computer science, and I'm going to place them on a shelf. How many ways can this be done? And we're going to look at a couple different criteria. So first of all, suppose there are no restrictions. Suppose I just don't care about having any organization to how I place them on the shelf, any particular ordering. As long as they all end up on the shelf, I don't care. If we have no restrictions, how many ways can we do this? Really, in this situation, all I care about is the number of books that I have. If we're going to count the number of ways, I don't really care about what subsets they might belong to. And so our total number of books would be, here's my 15 math books, my 12 physics books, 16 computer science books. This all adds up to 43 books. And so basically in part A, I just want to say, how many ways can I place 43 books on a shelf? How many different orderings? And so this will be given by the factorial, just 43 factorial. I think we could all probably see why this happens if we think about it from a multiplication counting rule perspective. So here's my first book. I've got 43 books to choose from, right? So I place the first book. Now that book's on the shelf. For my next book, I only have 42 books to choose from. Put that book on the shelf. Next, I've only got 41 choices, right? And so on. And this will continue until I've placed my very last book on the shelf. And by the time I only have one book left, that's my only choice. I've only got that one choice. And so here's our 43 factorial ways. If I don't care about the ordering at all, 43 ways I could place those books on the shelf. Now, of course, I think most of us might come at this from a different angle, and we say, you know, when I sort of place books on a shelf, I often like to have the same subject matter placed next to each other, so sort of have clusters, right? So now, if I want all the books on the same subject matter placed next to each other, let's just suppose, and we're going to have to consider different situations as well, but let's suppose I put my math books first, then my physics books, and then my computer science books. Right, so for my math books, once I place those first, well, I've got 15 math books. So the number of ways I could place the math books would be 15 factorial. And we could do this for the next two subjects. The number of ways I could place the physics books is 12 factorial. And finally, the number of ways I could place the computer science books there's 16 of those, so that's 16 factorial. So now, for each of these guys right here, for each of the 15 factorial ways I have to place those math books, there are 12 factorial ways then I could follow up with the physics books. And so here's multiplication counting principle. First I'm going to place the math books. Then I'm going to place the physics books. And then I'm going to place the computer science books. So 15 factorial ways to place the math books. Follow that up with my 12 factorial ways I could place the physics books. And for each one of those different permutations, I've got 16 factorial ways to place those computer science books. And we're not done quite yet because, of course, here I said suppose that we place the math books first, then the physics, then the computer science books. I could mix up that ordering. Maybe I want the physics books first, right, and then the computer science, and then the math books. And so how many different ways can I arrange the subject Well, I've got when I pick my first subject, which subject is going to go first? 3 subjects to choose from. Once I pick that, only 2 subjects left to choose from, followed by, if I only have 1 subject left, then that's not much of a choice. So this gives us altogether 15 factorial times 12 factorial times 16 factorial times, and we can go ahead and write this as 3 factorial or as just 6 if you like. This many ways right here. So many ways to place my books if I place the same subjects next to each other. Now you'll notice both in part B and part A, I didn't bother actually using my calculator to get an answer. As it turns out, these numbers are so huge that your calculator can only spit them out in scientific notation. There would be, I would think, probably 20 to 30 digits in both of these numbers if we did multiply them all out. So we'll just leave them written in the factorial form.